Hello everybody, this is Mrs. Dubois and I'm going to deliver the notes for solving a system. Hi, once again this is Mrs. Dubois and we're going to solve a systems of equations by graphing using Desmos. So a solution right here to a linear equation is any ordered pair that when substituted in makes the equation true. And when you graph it, that solution should be a point on the line. So you might ask yourself, like example 1, when I have the linear equation 2x plus 5y equals 9, is 2, 1 a solution? Well, we can do it algebraically where we plug in the values for x and y, and we follow the orders of operations, and we do in fact get 9 equals 9. Then we can also double check this or approach it from a different angle. We can put the equation in Desmos. And you can see when you graph it on Desmos that 2, 1 is a point on that line. Hence, 2, 1 is a solution. Now today we're going to start working when we have two linear equations, which is called a systems. A system of equations is two or more linear equations with the same variables. And the solution to a system of equation is any ordered pair that is a solution to both. Okay? And so we're going to approach this from Desmos today. So you will be asked the question, such as example 2, is 416 a solution? Now again, you can plug the 4 in for x and see if you come out with 16 for y. Or you can put both equations in Desmos and look at the point of intersection. And the point of intersection is 416. And hence 416 is the solution because it is true in both equations. Now I would like you to pause the video and graph this systems, and this systems of equations. And you want to check to see if the point of intersection is what's listed. So when you go to Desmos and you put in these two equations, you will find that they don't intersect. So 5, 1, the ordered pair, is not a solution. Same thing for example 4. When you put it into Desmos, both equations, you will find, yes, that they intersect at -2, 8. And for example 5, when you put in both equations, you will find that 7, 1 is not the intersection, so it's not a solution. And just a reminder that if we have a solution and are given an ordered pair, it has to satisfy both equations, okay? Not just one, but both. Okay, now we're going to do a little work by hand and see what it looks like when we graph it out. I have given you a systems of equations right here, and we're going to look for the point of intersection, but we're going to graph it by hand. I have also given you the input values for the x. So you're going to input 1, so for example, we'll have -5 minus 1, and that will give us y equals -6. So our output value will be -6. Then we'll have y equals -5 minus 2, which will give us an output value of -7. So again, I want you to stop the video, fill out the chart for y equals -5 minus x and y equals -3x plus 3. Then turn the video back on to find your answers. Okay, before we proceed to graphing by hand, you want to check your ordered pairs, your input and your output, to make sure it's the same as mine. And I'm going to graph a couple of points. So I'm going to do 1, -6, 6, then 2, -7, 3, -8, 4, -9, and 5, -10. And then I'm going to draw a straight line. Okay. Now I'm going to graph the other line. 0, 1, 0, 2, -3. Oops. Okay, 2, -3, 1, 2, 3. 3, -6.
With Haroon Verghese, please stop by the main office.
Sorry about that. All right, so we can see right here, if we draw our line, that our point of intersection is 4, -9. We can also see it here on the table. All right, so our solution is 4, -9. Now, if we straightforward just wanted to see what it looked like on Desmos, all right, we just put it in, and the point of intersection here is 2, 2. Oops, sorry. Same thing up here. I just don't want you to think that the intersection is always a whole number. All right, the intersection of these two lines is 0.4 and 4.4. Now we're going to approach word problems and systems, okay? So to become a member of a skating rink, you have to pay $30 membership fee and $5 every time you skate. For a non-member, it's $7 for the skating session. At what point will the cost be the same for a member and a non-member? So if you're a member, this is $30 and 5, so you have y equals 30 plus 5x. Non-members, you have y equals 7x. When you bring this to Desmos, and you should practice doing this while you're going through the notes, you will see that the solution, or where they intersect, is 15,105. So this means 15,105 is our ordered pair. This means at 15 visits or skating sessions, it will cost $105 for both, whether you're a member or a non-member. Example 10. A car dealership sold 78 new cars and 108 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. The number of used cars sold by the dealership has been decreasing by 4 cars each year. In how many years will the total number of used cars and new cars be the same? Use Desmos. So you want to pause, figure out what your two equations are, put them in Desmos, and see if you come up to the same answer. So if we're talking about used cars, it's 108 and 4 cars each year. So that is y equals 108 minus 4x. If you're talking about new cars, 78, and it's increasing by 6. So y equals 78 plus 6x. Go into Desmos, put in your points, and you will see that 396 is your point of intersection. That means in 3 years, should be an S, there will be 96 new and used cars. Sorry, and your point of intersection is 396. Okay, now we're going to move on to some new terminology, all right? When we put an equation as y equals, it's called function form, all right? A function form is a linear equation in the form y equals mx plus b. Or you'll get more technical in a little bit, and it will be f of x equals ax plus b. And if you think about all the systems that we did above, everything is written so y is on its own on one side, all right? But you can write equations multiple ways, and another term is called standard form, all right? And in standard form, it's ax plus by equals c. Something similar to that. where A and B are real numbers and both cannot be 0, and A is a positive whole number, meaning A cannot be negative and it cannot be a fraction. Okay? So we're going to use our skills of solving for equations, all right? So we're going to write the following equation in function form. So we're going to draw a line down here, and we're going to add 2x to each side. This will give us 0, and y equals 2x minus 3. Hence, y is on one side by itself, putting it in function form. Always good practice to put a line down the equals. We want to leave y alone, so we get rid of 3x. So you're going to have y equals negative 3x minus 2, and that is in function form. Moving on to example 13, we're going to get y alone, we need to subtract x from each side, so we'll have y equals 2 minus x. Now the last one adds a similar, another step, because you can see with the right here, like the coefficient of y is 1, but the coefficient of y in example 14 is 2. So we're going to work on getting this term by itself, adding 6x to each side. So we'll have 2y equals 10 plus 6x. Then we're going to get y alone by dividing. And when you divide, you have to divide each term by the same number. So we're dividing each term by 2. This is 5 plus 3x. And voila, we have it in function form. All right. And we're going to go back just one last word problem. Example 15, the Parks and Rec Department offers a season pass for $90. With the pass, you pay $4 per session to use the tennis courts, and without the pass, you pay $13, okay? So I want you to write the systems and take it into Desmos so that we can interpret our definition. Okay, so you're going to write a systems, okay? Y is equal to the total cost and X is equal to the number of times you play. So Y is equal to 13X. This is for when you have no season pass. When you have a season pass, oops, fancy, Y is equal to 90 plus 4X. That's when you have a pass. Okay, now if you bring both equations into Desmos, then you will see that the point of intersection is 10, 130. But what does that mean? All right, so if we want to stay organized, so what are the coordinates of the intersection of the two lines? 10 and 130. This means if you play tennis 10 times, it will cost you $130, whether you have a season's pass or you don't have a season pass. So I always think about it like 10 is your even point because the cost is the same. So now if you were a consumer and you were trying to decide whether to get a season's pass or not, this information would be valuable, all right? So if you only go 10 times, it's not going to matter. But if you go between 0 and 9, not sure who would go 0 times, but anyway, you would not purchase a season pass. It would not be the most economical. If you go more than 10, then the season pass is the best option. You will save money. Okay, thank you for listening to Systems of Equations.